Have you ever held your breath so you could float on water? Holding your breath makes you less dense than water. That's why you float. Density is a unique characteristic of a substance. It's equal to the mass of a substance divided by its volume. We can perform density-related calculations in a few ways. Let's take a look. Density involves three variables: density, mass, and volume. Instead of moving variables around when solving for one of them, it's easier to use the density triangle. The density triangle contains a D in the lower left corner, an M on top, and a V in the lower right. When solving for density, cover up D. And the equation you will use is mass divided by volume. When solving for mass, cover up M, and the equation you will use is density times volume. When solving for volume, cover up V, and the equation you will use is mass divided by density. Let's practice a basic density problem. What is the density of a 52-gram salt block with a volume of 20 centimeters cubed? If we cover up the D in the density triangle, we're going to take mass divided by volume. The mass is 52 grams. The volume is 20 centimeters cubed. When 52 is divided by 20 centimeters cubed, the result is 2.6 grams per centimeters cubed. Since 20 contained one significant figure, our result should also contain one significant figure, and the 2 in 2.6 should be rounded up to 3. So our final answer is 3 grams per centimeter cubed. Sometimes they prefer the answer in grams per milliliter. Since 1 milliliter equals 1 centimeter cubed, the answer will be the same in grams per milliliter. So 3 grams per centimeter cubed is also the same as 3 grams per milliliter. Let's practice a density problem that wants us to calculate mass. If 15.3 milliliters of water has a density of 1.0 grams per centimeters cubed, what is its mass? Cover up M in the density triangle and multiply density times volume. The density is 1.0 grams per centimeters cubed, and the volume is 15.3 milliliters. Our volume units don't match here. But since 1 milliliter equals 1 centimeter cubed, 15.3 milliliters is the same thing as 15.3 centimeters cubed. So we can multiply 1.0 grams per centimeters cubed by 15.3 centimeters cubed. Our result is 15.3 grams, because the centimeters cubed units will cancel out. Now, I have two significant figures in 1.0, so our final answer should contain two significant figures, and 15.3 will round to 15 grams. Let's practice another density problem that calculates volume. A piece of 3.8 grams of aluminum has a density of 2.7 grams per centimeters cubed. What is its volume in centimeters cubed? If we cover up the V in the density triangle, we're going to take mass divided by density. The mass is 3.8 grams. The density is 2.7 grams per centimeters cubed. When we divide 3.8 by 2.7, the result is 1.4 centimeters cubed. Each term contains two significant figures, so our final answer will also contain two significant figures. If I dropped a rock in a graduated cylinder and the volume rose from 5.0 milliliters to 8.0 milliliters, the volume of the rock is equal to the final volume minus the initial volume of water in the cylinder. So the rock has a volume of 3.0 milliliters. This is called calculating the volume by displacement. We can use this concept in density problems. In the lab, when calculating the volume of an irregularly shaped object, make sure it is fully submerged in water before you determine the volume. Sometimes we are given a list of liquids and their corresponding densities and asked to arrange them in a graduated cylinder. The liquids with the highest densities will be at the bottom of the cylinder, and those with the lowest densities will be towards the top of the cylinder. Let's practice. Where will the following liquids fall if poured into a graduated cylinder? Well, dish soap has the highest density, 1.03 grams per milliliter. So it is going to fall at the bottom of the graduated cylinder. Water has a density of 1.0, so it will form the middle layer in the graduated cylinder. Motor oil has the lowest density, 0.9 grams per milliliter, and it will form the top layer in the graduated cylinder. For more practice and a typed script of this video, or to schedule a private or group tutoring session, go to www.nicolemabante.com.